So we've already worked with distribution when we're not dealing with fractions. Let's take a review of that. Suppose I want to multiply the monomial 2x times negative 3x. Since I'm multiplying a term to a term or a monomial to a monomial, we call that distribution. So distribution is a special term or a special word for multiplication when we're talking about multiplying one monomial to another monomial. And there were three things to consider. First, you had to consider the sign. In this case, I have a positive times a negative. And we're going to use the multiplication property for this. If I multiply a positive times a positive, the result is going to be positive. If I multiply a negative times a negative, the result will give you a positive. If I multiply a negative times a positive in either order, the result will give me a negative. Next, I have to consider the numeral. The numeral is really the coefficient, the number part, and number would be with air quotes because the truth is 2x altogether is one number. And so the part of the number that we're used to working with, the numeral or the coefficient. And that's just what we're used to working with already. The numeral 2 times the numeral 3 would be 6 in this case. So we're just going to multiply the numeral times the numeral. And thirdly, we want to count our variables. So if I if I multiply this x times this x, how many x's do I have? I have 1, 2 of them, and so I'm going to write it as x to the second power, meaning that I'm multiplying two x's to each other, or 1x times itself twice. So let's do an example with integers. Let's do 2x times negative 3x. So first deal with the signs. I have a positive times a negative, and my rule says that when I have one of each, the outcome is going to be negative. 2 times 3, taking the numeral part next, 2 times 3 is 6. And then looking at the variables, I have 1, 2 x's, and so I'm going to write it as x squared. So the result of multiplying 2x times negative 3x is negative 6x squared. So when we multiply with fractions, we're going to do exactly the same thing. The difference is, unlike here where 2 times 3 equals 6, with fractions often we don't know the result right away, or we can't see the result in our heads right away. So we're going to use an intermediate step. In this case, I'm going to represent the numeral, the number 2 or the number 3 or wherever the numeral is, as letters. So suppose I'm multiplying a times x times, and I'm going to keep a negative just because it keeps our example consistent, times negative b times x. And I'll show you what is different if I carry it out writing down the middle steps. So in this case, I look first at the sign. I have a positive and a negative, so this will be a negative. And then when I multiply the a times b, I can write that down, a times b. Notice when I multiplied 2 times 3, I didn't write a step here in the middle. Let me put it in now. So in this case, I would have a negative, and then 2 times 3. I could have written 2 times 3, and then count my variables. X, I have 1, 2 of them, so x squared. So the step I didn't write down with integers is right here. I didn't write it down with integers because 2 times 3 is easy for me to do in my head and just write down. But now that I'm working with fractions, this middle step is very useful because I don't have to really think about it while I complete the rest of the problem. And that's what algebra is about. It's about putting things down on paper while you process the little parts and you don't lose the parts that you're not working with yet, which is really easy to do in some of these more complicated problems. So let's do our first example with a fraction. I'm going to use exactly the same number that I've used here, the same two numbers, only instead of 2, I'm just going to write it as 1/2. That way I can represent the lesson of working with a fraction without changing what we've already done too much. So you can hopefully see the distinction between working with a fraction and working with integers. All right, so I've set up the problem. Now I want to start with sign, because that's our first step. So a positive times a negative is a negative. And then I want to multiply the numerals. And some of you may already see the answer directly. What is the result of 1/2 times 1/3? And some of you may not. Let's say that none of us can. It just means I want to write that part out. So I know that I've already got a negative result, and the result is going to have a negative, or excuse me, going to have a 1/2 times a 1/3 in it. So I just write that down, don't have to think about it, and then finish up the rest of the steps I have to go through to multiply these two numbers. So I'm going to count the variables. So I have an x, and I have how many of them? 1, 2. All right, so now it's easy for me to, without worrying about making a mistake on the sign or making a mistake on the variable, because they're already written down for me, I'm only going to deal with this part. And of course, this one is pretty easy to do in our head, because multiplying fractions together, you multiply across the numerator and then multiply across the denominator and bring down the x squared. And so writing that middle step, where instead of actually doing the calculation of 1/2 times 1/3 in your head, if you write it down, it gives you some breathing room to not make a mistake and to not get lost in the problem. So that's a distribution of a monomial times a monomial. Even if the numeral or the coefficient is a fraction, you do exactly the same process as if the coefficients are integers, except you have to deal with the fact that you're dealing with fractions. What happens though if you're multiplying a monomial times a binomial? So let's look. Let's multiply 2, which is just a monomial without a variable on it. 2 times negative 3x plus 6. Okay, so that means I have to take this first number 2 and multiply it into each separate part of the second number, a monomial times a binomial. So first things first, let's look at the sign. I have a positive 2 and a negative 3. So this is going to give me a positive times a negative is a negative result. Then I'm going to deal with the numeral. 2 times 3 is 6. And then I want to count variables. And so the variable I'm working with is x. And how many of them do I have? I have none here, plus 1 here. So that's just 1. That means now that I have multiplied the first number times the first part of the second number, and I'm done with it. Once I do that multiplication, I'm done with it. Now I want to multiply 2 times the second number. So first things first, look at the sign. This is positive, this is positive. 2 positives makes a positive. Then the numeral, 2 times 6 is 12. And then the variable. I don't have any variables, so there's nothing else to write. Then I have to look to see if I can combine any terms. And in fact, negative 6x, this is an x term, and this is a constant term. They can't be combined. So this is my final answer, doing this with with an integer. So let's do an example with a fraction, using our middle step if we need it, and using the same process I used here to demonstrate monomial times a binomial. So let's take 1/2, just mirroring the numbers again, times negative 1/3 x plus, let's call that 1/6. Okay, so I'm going to do exactly the same thing here, except I'm dealing with fractions, which means I have to consider the special rules that go with multiplying and adding and subtracting fractions. So first things first, I notice that I have a monomial times a binomial. This is a number with 2 parts. So I'm going to start by multiplying the first number times the first part of the second number. A positive and a negative is a negative. 1/2 times 1/3, let's just save that. and then add up my variables. Well, I'm dealing with an x and I only have one, so that's all I have. I could write the 1 there if I wanted. We don't tend to do that, but I could if I wanted to. So now I finished working with that first term, first part of the second number, and now I want to multiply the monomial into the second term. And so that's a negative, excuse me, a positive, and a positive is a positive. 1/2 times 1/6. And there are no variables to deal with. And so that's my middle step, where instead of doing the calculation in my head, as I could with integers, I've just written the calculation down. Here I went 2 times 3 is 6 because that's easy for me to do with integers. But here I had to say 1/2 times 1/3. It was too hard for me to do in my head, so I had to write down 1/2 times 1/3, and then I could calculate it afterward. So let's go back down to our last example and finish up. I have a negative. 1 times 1 is 1. 2 times 3 is 6. Just bring the x down. Plus, and now do this portion. 1 times 1 is 1, and 2 times 6 is 12. And then last but not least, can I combine like terms? And in fact, this is an x term. This is a constant term. I'm done. So let's do one last example using fractions that aren't pretty or aren't modeled after our integer problems. So let's take 2/5, and we're going to multiply that by 3/4 b minus 5/8 c. Let's put a variable on both terms inside of our binomial. So following the steps, I'm going to take the first number, multiply it to the first part of the second number. Using our 3 steps, a positive and a positive is a positive. 2/5 times 3/4, oh, too much for me to think about right now. And then step 3, deal with our variables. So I have a b, and how many do I have? I have 1 and no more, so just 1. I'm finished with that term. So now let's multiply to the next term. Positive and a negative is a negative. 2/5 times 5/8, again, don't really want to deal with that at this stage. And then the variables, my variable I'm dealing with is c, and I have 1 and no more. Now I can do these multiplications and not worry about the positive, negative, not worry about the variable configuration, just have to worry about my fractions. Multiply across 2 times 3. Well, before we multiply across, remember, you always want to reduce a fraction as soon as you can. And since these are 2 fractions multiplied together, that means I'm going to have 2 factors in the numerator and 2 in the denominator. I can certainly go ahead and cancel. 2 divides by 2, leaving a 1, and 4 divides by 2, leaving 2. 3 and 5 can't be reduced with each other, so I'm going to go right on ahead and do my multiplication now. 1 times 3 is 3, and 5 times 2 is 10. B minus, notice I just had to write the next things down until I encounter the next fraction. This fraction has a 5/5. Those both cancel because 5 divides by 5, leaving 1. 5 divides by 5, leaving 1. Done. The other numerator to denominator, 2 divides by 2, leaving a 1. That's great. And 8 divides by 2, leaving a 4. So now when I put this together, I have 1 times 1 in the numerator and 1 times 4 in the denominator. I've multiplied my fractions. I'm going to move on to my variable. And that's my final answer. So I know I'm close to the time limit I like to keep for myself, but let's do one more example just because I think it's kind of useful to see. Let's do an example that puts the variable or puts a variable outside. So 3/4 x times 1/2 x plus 1/3. Okay, so let's see what we get here. First number times the first part of the second number is going to give me a positive, and a positive is positive, and then 3/4 times 1/2. 3/4, and I'm going to write it this way this time, just for variety, because we can write it so many different ways. Let's have a practice looking at what that looks like. And then my x is my variable, and how many do I have? I have 1 and 2. Okay, finished with that first term, cross it out. 3/4 x plus 1 times positive 1/3. Well, a positive and a positive is a positive. 3/4 times 1/3, just write that down so I don't have to deal with it yet. And then there's an x variable that I'm working with, and I have 1 here and none here, so I'm just going to have 1x left. Now I can deal with my fractions. Let's do reducing first, see if I have anything. 2 and 3, and none of these have shared terms. 4 and 2 have a shared factor, excuse me, none of them have shared factors. 4 and 2 have a shared factor, but I can't cancel because they're both in the denominator. So let's just do that multiplication. 3 times 1 is a 3, 4 times 2 is an 8, and that's an x squared term. Plus, see if I can cancel here. Well, look, I have a 3 in the numerator and a 3 in the denominator. Those both cancel, becoming 1s. And so now I can do those multiplications super easy as well. 1 times 1 is 1, 4 times 1 is 4, and that has an x term. So that's distribution with fractions using the exact same steps we used when we did distribution with integers, except now we want to keep this middle step so that we can process our fractions separately from processing the distribution of polynomials. Two different things that you have to do, easiest to keep them as two separate steps. First, make the distribution. So in this case, from here to here, multiplying these together, make the distribution without calculating the fractions, and then come out and calculate the fractions. And you could really see it in these problems, like this one made a huge difference, right? You're going to make the distribution first, but don't process the fractions until after. And then when you process the fractions, you have all these great reductions that you would never have been able to do in your head. Okay, maybe you would have, but almost never be able to do in your head. Some problems you can, but often you can't. And so if you can save out your multiplication of fractions for another step, then you can do all these great reductions and go right to the final answer without having to multiply and then reduce later.